Sorry about that. Had to take a call from one of the teams I work with. Anyways, I was saying that if you now have a 30% larger heart, so your heart holds and pumps 100 mils per minute instead of 70 mils per minute, and you need to pump 1.5 liters of blood per minute in order for your body to stay normal. Now that your heart can pump a lot more blood, now what it has to do is it doesn't have to beat as frequently. So instead of beating 70 times a minute, now it can beat significantly fewer times. Okay, so now what you're doing is your baseline heart rate goes down, or your basal heart rate or your resting heart rate goes down, because each pump of the heart carries more blood, so your cardiac output is maintained with fewer heartbeats. And that's why somebody who's really fit is going to have a resting heart rate between 40 and 50, whereas somebody who's not doing so well is going to be around 70 beats per minute. All right. So what is the heart trying to do? So this is a study again out of Stockholm, Sweden. And this is a study that you only really could do in the Scandinavian countries, because this is a human study where what they did is they measured your VO2 max. So again, maximum oxygen uptake, that's your VO2 max. What they had these individuals do is they had them breathe high levels of oxygen, so pure oxygen in a tube or in a mask, just at control levels. And then what they used this HBCO. And what the HBCO was they exposed these people to carbon monoxide. So carbon monoxide, you all have a detector in your house that's a carbon monoxide detector. The reason for that is that carbon monoxide kills you. The reason that it kills you is that carbon monoxide binds irreversibly to the protein that carries oxygen around your blood, hemoglobin. So basically, if you're in a fire and you are going to have asphyxiation problems because you can't breathe, it's the carbon monoxide. It binds to your hemoglobin, so your hemoglobin can't bind oxygen, so you can't transport oxygen. So basically what these researchers did, is they took all of these subjects, they put them into the equivalent of this huge house fire, and then instead of taking them directly to the hospital where they belonged, they put them onto a bike and they had them exercise as hard as they possibly could. Yeah, not something you would get many people to do. Anyways, what you can see is in every individual, the red dot is when they were breathing pure oxygen. The open dot is when they had normal air, which is it's around 20% oxygen instead of 100% oxygen. And then the open circle is when they had given them carbon monoxide to basically take up a bunch of their red blood cells so that they couldn't transport oxygen as well. And every single person, the red is the highest, the black is the next, and the open circles is the lowest. And you can see that there's usually this linear relationship, and the average is this big line here. And what this is telling us is that what the heart is doing, by cardiac output being the limiting thing for VO2 max, is that what you're doing is that heart is pumping blood that carries oxygen. And your ability to transport oxygen is really the key to your maximum oxygen uptake. So the more oxygen you transport, the more your VO2 increases. So a lot of people who are athletes will train at high altitude. At high altitude, what happens? Your body takes the low oxygen tension to mean that it needs to produce more red blood cells. So you have more red blood cells. If you don't want to go to altitude and you want to cheat, you can either use blood doping, which is when you take your blood out, you get rid of all the liquid from it and you store the red blood cells. You then, over time, regenerate your red blood cells, and then as you get close to the race, you inject them back into you, and now you have significantly more red blood cells. Or you can take the drug erythropoietin. And erythropoietin, what it does is it tricks the bone marrow in your bones to think that you need to generate more hemoglobin, more red blood cells. And so what it is a way to trick your body into producing more red blood cells. The more red blood cells, the more oxygen you can carry. The more oxygen you can carry, the higher your VO2 max. The higher your VO2 max, usually the better your endurance performance. And that's why a lot of athletes like cyclists or runners will go through these processes. All right. In fact, the first known person to be blood doping wasn't really blood doping. This is this incredible person named Eero, and go ahead and try and pronounce his last name. He's a Finnish individual from Finland. You can see he's quite an incredible athlete. 3 Olympic golds, 2 silvers, 2 bronze, 2 world championship gold. He was special, and his family is special. And if you go to him now, he's in the middle of this place where he's always covered up. He's basically in snow year round. And yet you go to him and he's got this beautiful tan. He's looking he's looking bronze. And really what it is that he's got really high blood hemoglobin. So he's got 25 to 50% more red blood cells than an average individual. Why does he have that? Because in this population of Scandinavians, what his family has is a mutation in the receptor for that protein that I said that you can inject, that drug that you can inject, erythropoietin. And so the receptor for this has a mutation in it that makes it think that it always needs to make red blood cells. So his body is always making many, 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 many more red blood cells than our bodies. And as a result, he's got more red blood cells in his blood, and he can carry more oxygen, and he can become this incredible Olympic athlete. And again, this is one of these questions of where does cheating begin and genetic modification or genetic mutation, where does that end and cheating begin? But really what it's telling us is the higher your red blood cell count, the higher your endurance capacity, the higher your endurance performance.